let's continue our math adventure. Remember, number theory is just giving us some basic concepts about how numbers work in math. So today we're going to work with something called scientific notation. And it truly is mostly used in science. That's why we call it scientific notation. Now, it's used with really, really big numbers or really, really small numbers. So in science, probably this could be something to do with astronomy. Anything with space would give us enormous numbers. Also, it could be dealing with something like atoms. Atoms are tiny, tiny, tiny particles in science, and so we might want to use scientific notation when we're talking about atoms and the size of them. So numbers that are just written regularly, that's called standard form. But if we want to change any number to scientific notation, what we're doing is we're actually just moving decimal points. So right now in this standard form, this enormous number has a decimal point right at the very end. And I know that every time I move a decimal point over, it's by a power of 10. And every time I do that, that would be like dividing by 10, dividing by another 10. So really what I'm doing is I'm dividing or multiplying by powers of 10. So all I need to do is count the number of digits that I move that decimal point over. Now, scientific notation, we always keep one number in the ones place, and we always want to move that decimal point to right after that first number. So I know that I need to move that decimal point all the way over to right here. So I'm going to count how many times I actually do that. So let's just move that decimal point till we get to that first number. And I've got to stop right there. And I'm going to count how many times I actually moved that number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. So part of scientific notation is we always do times 10. And this is a positive exponent. And we're going to count how many digits we actually moved that number. So I moved it 12 places. But I still have to account for the digits at the start. So what I do is I take that first digit, 3, and I place it before the decimal point. Any numbers before your string of zeros also have to be accounted for. So I have to include that 4, 5, 2. And I'm going to put that right after that decimal point. Once I get to this string of zeros, I stop. That's when I say times 10 to whatever number of places I move that decimal point. So standard form and scientific notation form look entirely different, but they mean the same number. And this smaller way of writing that number really does help scientists whenever they're dealing with very large numbers or very small numbers. So let's now take a really small number for that. Well, if we have this number, the concept is still the same. And so what I'm doing is I'm moving that decimal point, and I want to move it so that it goes just beyond that first digit, because I'm going to keep the same format that I had before. So I'm going to stop that decimal right after the 8, and I'm going to put 8 in that ones place. I'm going to follow it by the decimal point because we do the same format, and I have to include any numbers beyond that 8. So I'm going to put my 0, 3. Now I'm still going to multiply by 10, because that's always what we do with scientific notation, because it's about the movement of that decimal point. And I'm still going to count the number of digits that I moved it. So I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. But whenever we're moving it in really small numbers, we use negative exponents. So I can tell in scientific notation if a number is big, if it has a positive exponent, and I can tell if a number is small, if it has a negative exponent. Now, how does that help us actually when we're doing our math? Well, sometimes I want to multiply really, really huge numbers together, and there would be a lot of zeros, and it would take forever for me to actually calculate it. So what I do is I change any of these enormous numbers or small numbers into scientific notation, and then I can use my rules of exponents to help me multiply them. So when I take 6 times 10 to the 7th power and multiply it by 9 times 10 to the 5th power, well, the 6 and the 9 have no exponents with it. So I'm able to just multiply those two numbers together. So 6 times 9 is 54. Now I can use my rules of exponents because I know that if the bases are the same, all I have to do is add those exponents. Well, I have a base of 10 and a base of 10. So I can say times 10, and I'm going to add the exponents that go with it. So I get 54 times 10 to the 12th power. But I have a problem here, because by definition, I can only have one digit in the ones place. And right now, my decimal point hasn't moved far enough. So this is called correcting the format. I need to move my decimal point one more place value over. So in order to move it that extra place, I need to add one more place value to that exponent. So in the end, with corrected form, the correct way to write this multiplication problem would be, my answer would be 5 4/10 times 10 to the 13th power. Now we can also do it with really small numbers, and I know these are small because I have negative exponents. So I'm going to do the same thing here. I'm going to multiply the 8 and the 7 together, and I get 56. And I'm going to do times 10, and I'm going to still use this rule of multiplication with my exponents. So I'm going to add negative 2 plus negative 7. So I get 56 times 10 to the negative 9th. But I have a problem, because this is not the correct format. I went too far. I have too many digits. I've got to move this decimal point back one place so that I can get 5 6/10. That means I went too far. So I've got to take one away from there. So instead of being negative 9, it's going to be negative 8 to account for moving that decimal point back one position. So in the end, my answer to this problem would be 5 6/10 times 10 to the negative 8. The biggest mistake kids make is they don't look at that final answer and correct that format. And it's up to you to make sure that you always have a single number in the ones place, followed by the decimal point. Any numbers before your string of zeros, then you do times 10 to your whatever your power is. So it seems like a complicated concept, but it really is not that complicated if you just remember those basic principles. Now it's up to you. Are you up for the challenge?